Okay, let's look at this last fractional first principle calculus question. They're a little bit trickier, and let's just try it. You've got f of x equals 2 over 3x, and it says determine f prime of x, the derivative of x, from first principles. So you've got this formula they give you on the formula sheet, that f prime of x equals the limit of, as h approaches 0, of f of x plus h. So what does that mean? It means you just rub out the x and put x plus h. And then minus f of x. Well, there's f of x, minus f of x. So that's your first mark. Pretty easy. Now, this is the slightly tricky part. You've got a fraction here. And the way you combine fractions is you take the denominators of both fractions and you multiply them together. And then you cross multiply. 3x times 2 and 3x plus h times this minus 2. And that's what you get here. Now here's the little tricky part. This is really h over 1. It'll make this whole thing work out if we tip in times and turn it into 1 over h. And now it kind of moves over there. What did we do here? 3x times 2 is 6x. 3x plus h times 2, well, that'll be 6. It'll be minus 6x, and it'll be minus, see, 2 times 3, but it's minus 6h. Okay, whoa, 6x minus 6x, that's nothing, so that's pretty good. And these h's now, 1 over h times 6h, the h's cancel. And all you get is minus, well, I'm going to do that in the next step. 6x minus 6x, it's gone. You've got minus 6h, and now the h's are going to cancel. I multiplied this out, made it 9x squared and 9xh. The h's cancel, and now you're kind of looking at your answer. You see, if h became infinitely close to 0, this 9xh, no matter what it would, become 0. So the rate of change at any value of x is just going to be minus 6 over 9. X squared. H approaches 0, this falls away. Well, 6 over 9 is the same as 2 over 3, so this is the derivative. Now, the last question Mr. Autry asks in his notes, he says the challenge is to see if you can see a pattern emerging. This pattern will allow you to do it in one step. Now, I'm not going to do it. I'm just going to sort of summarize a lot of the questions that we did. If we have 3x squared minus 5, the answer is 6x. Well, how could we get that? Well, that's interesting. There's a minus 5, but there's nothing there. So you have to think, okay, I learned something there. Now, how did I get a 6? There's a 3 and a 2. Maybe there's something we can do. Let's look at the next one. This 2 over x is pretty weird. Just 2, and then it turns into x squared. That's pretty weird. But let's try this one. There's a 3. The 3 goes in front. Oh, just look at that pattern there. And then the 3 turns into 2. Look at this one here. 2 and 2, and then there's a 4 there. And instead of x squared, it's x. But the number 4 there, we're finding the derivative. Well, look for a pattern. What's happening here? Look at this one. We've got 4x because of the 2x squared, I guess. And then it turns into minus 3. So the trick here is to kind of come up with a rule. Here's x squared turns into 2x, and then plus 3 when it was 3x. See if you can think of a rule of how you could get there. Instead of doing all of these steps, just do it in one step. There's a rule, something's happening with these so that you can find the derivative in one easy step. It's kind of, if you can see the pattern, it'll make it easier to remember it. And then we have a minus x squared plus 3, and look, it's minus 2x, the derivative. And the last one's a fraction thing. Look at that, 2 over 3. Just like this one was over x, it turned into x squared. This one turns into x squared. I'll have to think about that. Anyways, you study all these and see if you can come up with a rule for finding the derivative in just one step.